Hello, we're going to be doing some maths for fun, and we're going to be finding the integral of x dx, but without any knowledge of basic rules of calculus, just by making things very overly complicated. And the way we're going to do that is we're going to write this as the integral of ln of e of x dx. And instead we're going to deal with this integral here. And the way we're going to do that is by doing a u substitution. So I'm going to say that let u equals e to the x, the thing in the argument of the log. And then I'm going to differentiate this. E to the x differentiates to e to the x. And then I'm going to rearrange this for dx so that I can go from a substitution, go from an integration in x to an integration in u. So I can rearrange this and write it as 1 over e to the x du equals to dx. Bringing that up, bringing that one down. And I know e to the x is u, so I can change that around. I really have 1 over u du equals to dx. And now I'm going to substitute this all up into this. So really, I'm finding the integral of ln of u times 1 over u du. Have I made it easier? Let's see. The way we're going to integrate this is by parts, using this formula down here, because we have the product of two functions. The way we're going to do that is the one that I want to eventually differentiate is going to be ln u. This is what I'm going to want to eventually differentiate. So I'm going to write this one down as u. So this is going to be u, and this is going to be v dash. U and v dash. So using the formula down here, the integral of this is going to give me, write one down, integrate the other, that's going to be ln u, minus the integral of this one times the derivative of this. And the derivative of ln u in terms of u is just 1 over u. So really, this is the same as this. We integrated this by parts, we got this. And you might notice we have some things in common. We actually have that this is exactly the same as this. So we can use a really cool integration trick and just kind of solve this. So we're going to bring this to the other side, or we're going to add this to both sides. So really, we've ended up with two lots of the integral of ln u 1 over u du equaling to this, which is ln of u all squared. So we just times them together. Divide both sides by 2. Because now we're going to get that the integral of ln u 1 over u du is actually equal to a half of ln u squared. And remember, this is just what we were trying to do right at the beginning. So we found that the integral of this, after a bit of hard work, is equal to half ln u all squared. But we're not finished because we're trying to integrate in terms of x. So I can replace this. We know that u equals e to the x. That's what we said up here. So this is actually a half of ln of e to the x squared, but ln of e to the x is just x. So this gives me a half x squared plus c. So the integral of x dx is obviously a half x squared plus c.